Alright, so here's your review for your test. So your test is Monday. A lot of these look like your Math Excel. The first one says tell why the two triangles are congruent, give the congruent statement, and then list all your corresponding parts. So this is a side. I'm going to mark it as S1 because it's got one mark. And here's the corresponding one. And then this is S2, which is also right there. And then this is an angle. So it's side, angle, side. So that's this one. And then this says EFD. So I'm going to say 1, 2, 3. The E is going to correspond to the X. And then the Z corresponds to this one, and then the Y. So you want X, Z, Y. So the reason, again, why it's side, angle, side is it's the angle between the two sides that are marked. That's how come it's side, angle, side. Okay, the next part says list all the other corresponding parts, and so E doesn't have a mark, and X corresponds to it, so it's E equal X, which is this one. And then F doesn't have a mark, and it corresponds to Z. So F congruent to Z. And then the side that's not marked would be the EF to the XZ, which is this one. So it's all three of those. Okay. Number 2, complete the proof. You've got these two angles that were given because they're up there. And then this is reflexive when it's the same thing. So what we have is angle 1, then the reflexive side, and then angle 2. So this is angle, side, angle. So that's this one. Then after you know your triangles are congruent, then you use CP/CTC. Corresponding parts of congruent triangles are congruent. Any questions? Okay, number 3. This one, you have a stringed instrument, and it says prove the bases are congruent. So this was your given information, and looks like we have one side and two angles. So just based on that, I can rule out that it's not SAS or SSS. Then I have to look at the figure to figure out which of these it is. RA, okay, that's this one. Angle R, I'm going to call that angle 1. And angle A, I'm going to call that angle 2. So ASA. And then after the triangles are congruent, then CP/CTC. Any questions? Okay. Number 4. This is up here, so that's the given. Remember, if it has a little 1 or whatever, that's multiple choice. There are a couple of them later where you have to fill in a few things, but you don't for this. And then this one has the same thing, which is the reflexive. So this would be side 1, this is your angle, and this is side 2. So that's side angle side. Then after you know they're congruent, then you do CPCTC. Okay, the next one. This one says mark the original figure and explain how you would prove these, and this is your given information. So we have PK congruent to Q, okay, and so that's this one. This one says bisects, so that means KL bisects PKQ, like this angle equal to this one. So based on what we've marked, it's B, because these are marked and then these angles are marked. On a different one, it'll say perpendicular bisector, so it's going to look like this with a right angle. But yours for number 5 says bisect, so that means this is equal. Any questions? Okay, so then once we have that, then we have a small proof here. Given that those are equal, also use, it said bisect, and so it's going to be definition of angle bisector. And this part we hadn't done yet, but it's the reflexive side. So this is your side 1 angle, side 2. So you have a reflexive, and it's side angle side. Finally use CPCTC. So hopefully you notice the pattern that you use one of your congruence things and then CPCTC. Okay, so there's number 5. Number 6, similar question, but this time it says perpendicular bisector. So you're going to have a right angle and then these equal. So that's D. So that's the difference between bisector and perpendicular bisector. Perpendicular bisector makes these two segments equal with the 90. Okay, so then first it said perpendicular bisector, so we're going to use the definition of perpendicular bisector. And then this is side 1. And it also says use blank to show these angles are equal. I should mark it on D. Okay, so these angles are equal, these 90-degree angles. And so if it's related to 90 degrees, then that means it'd be perpendicular. So I put since 90 degrees, because that's what perpendicular means. Then part 3 says KL congruent to KL, which is your reflexive. So this was the side, this is the angle, this is the side 2, so it's side angle side. And again, CPCTC. Okay. Next we have the longest proof in the whole packet. Okay, so to start with, this one has AE plus EF equal AF. It's not up here, and so you have to look at the figure. It's saying AE, which is small, plus EF, which is medium, equal large. So small plus medium equal large was the segment addition. Something we had a long time ago. Segment addition postulate. Okay, the next one we have AF congruent to CE, which is this one, and so that's given. So 2 is given. So far, segment addition, I put small, medium, large right there, and then given. So now this is why this is like the longest proof ever, so to speak. You're going from this to this, which we usually skip over. That's just definition of congruence. So on 3, definition of congruence. It was the exact same letters. All they did is they took off the bar and the wavy line. So that's definition of congruence. Okay. The next part says AE plus EF. Okay, so that's right there. Is equal to CF plus, and it's going to be EF. This part is required, or it'd be like -1. Same thing for this part. These are all multiple choice. But these parts are not. Okay. So it's EF for both of those. And then what they do is they're subtracting EF from both of them since it's in that. So 4 is subtraction. They're basically taking away EF from both. So subtraction. And then they're doing the same thing they did earlier. They're going from this one with equal to this one with congruent. And so that means that number 5 is definition of congruent. If it looks the same thing except it now has bars or the wavy part, that's definition of congruence. Okay, then number 6 for this, the 6 blank, it's not number 6. These things about the perpendicular symbol is up here, so that'd be given. Don't get mixed up with this 6 being for this, because it's really to this one. Okay, so that was the one that was given. And then this about right angles. Okay, well, if you know they're perpendicular, then they're going to be right angles. Let's look. BE perpendicular to AC, which is angle AEB. So these two have to relate to each other, and so it'll be definition of perpendicular. So it's not on this page, it's on the next, and it's the definition of perpendicular. Definition of perpendicular. Remember, perpendicular is the upside down T. Okay, then once we have that, then they're saying they're equal to each other, and it's the exact same angles, and so it would be all right angles are congruent. All right angles are congruent. Okay. Then we have to mark this. AEB, well, those are equal. Then they have BE congruent to DF, which was our third piece of given. And so, even though we don't usually have given near the end of the proof, we do for this one. Number 9 was given because this BE congruent to DF was in our list. So that's why that's given. Then they have SAS, so they finished proving the triangle's congruent. We've got to put this part. AEB would correspond to CFD. CFD. So basically the A corresponds to the C, the E to the F, and the B to the D. So basically, this to this, this to this, this to this. Okay, so once you put that, then that was from side angle side. These are now equal from CPCTC. Corresponding parts of congruent triangles are congruent. Okay. The next one, we have JK parallel to QP, which was given. And then immediately after that, they have angles. So remember what I've said before, if you've got parallel lines, then most likely you're going to use alternate interior. So this angle equal to this angle is alternate interior because KQ is your transversal. So that's going to be alternate interior. Okay. Alternate interior. And then they have another set of angles, KJM, congruent to these. That's also alternate interior. It's just using a different transversal. So, alternate interior for 2 straight. So that was based on those lines being parallel. You have this. Now you have JK congruent to PQ, which was up here. So 4 is given. And then 5 is over here. Which postulate is it? So this is angle 1, side, angle 2, ASA. ASA. Okay. Then they have JM congruent to something, and again, this part is required. JM are the first and third, and PM are the first and third. So you put PM right there. and they put that from CPCTC. Then this one says midpoint, so this is going to be definition of midpoint. This one says bisect, so it's going to be definition of bisector. So definition of midpoint first, and then definition of bisector second. So you basically just look for the word that's across from it. Any questions? Okay, now some shorter questions. This one says RS is 5 and RU is 10. And it's talking about the perimeter, which means the outside. So you got 5 times how many sides? A hexagon has 6 sides. If you wanted to, you could count 1, 2, 3, 4, 5, 6. And so you get 30. 5 times 6 is 30. Okay. Then number 10, it says explain why the thing is true after you name the theorem. So first they're saying this is side 1 angle, and then this would be the reflexive side, which is side 2. So you have side angle side. Okay, so first you had to name your theorem, and then after your triangle is congruent, then this is going to be CPCTC. It's not given, because it says then explain why this is true. So there's your CPCTC. It's not given. Okay. Now this one says QP congruent to something. So that'd be QS. And it's because your angles are equal. Now, when we're looking at this, we first want to say it's got to be one of the QP to QS ones. So it's not A or D. And then you got to look at the difference between these. This one says connecting, which would indicate it's a base. This one says opposite, which indicates it's about a leg. So we've got these, which are making these equal, which are legs. And so that's going to be C. So basically, this is a leg, and this is a leg. So don't choose the one that says connecting, choose the one that says opposite. That's your key word. Any questions? Okay, then on this one, ZY is congruent to VX as well as VU. And again, it's about opposite, not connecting. Okay. Number 13, angle FJE. This one would be equal to this one because these are corresponding angles and these are corresponding. And we also have these sides equal. So it's going to be the FJE angle, which is on all of them, equal to FEJ. So this says FEJ, this says EFJ, which is wrong. Here's an FEJ and here's a EFJ. So again, what's the difference between it? This says connecting them, which again would be a base. This says opposite, which would be a leg, and it's about the leg. Any questions? Okay, so now for some number questions. Find the values of x and y. So this one's 2, which makes y 2 because they're the same. And if they're the same, or since they're the same, then this would be a right angle since it's the perpendicular bisector. And so that means if this is x, so is this, because they've got those marked. And so basically these two would be complementary angles, which means you're going to want to do 90 minus 54 and get 36. You could have said 90 plus 54 is something and then 180 minus that, or you can just use that these are complementary. Because if this is 90, those have to add up to 90. Any questions? Okay, this is 125, and so you do 180 minus 125 to get 55, and that's what y is also. And then you say 55 times 2 is 110, and so you go 180 minus 110 is 70. Okay, sorry, this one says vertex angle is 84. So you do 180 minus 84 is 96. And then divide that by 2 and get 48. So the base angles are 48. Okay, so that one you just subtract and divide by 2. Now we have another proof one. This one again I recognize from a Math Excel. So it's saying something's the bisector of this, so it's RS, and then RS for that also. And then in the proof, it's going to be reflexive. Okay, the next part is saying PRS is congruent to something. So PRS would be this angle. It's congruent to QRS, this one. So QRS, top choice. And then after that it says P is congruent to Q, which was marked already. It says begin with that, so that means it's given. Okay, then you're choosing from these, and so this would be angle 1, angle 2, and reflexive side, so AAS. It's the AAS theorem. The others are postulates, that one's a theorem. Okay, then once we know the triangles are congruent, then for this spot we put CPCTC. All right, number 18, the length of the base of a triangle is x, and the legs are 5x minus 3. That means it's going to be a short base but long legs. And they're talking about the perimeter. So you'd say x plus 2 of these equals 104. Or if you'd rather say x plus 5x minus 3 plus 5x minus 3. Those are equivalent. So now I want to distribute, so we get x plus 2 times 5x is 10x, 2 times negative 3 is negative 6. Then you do x plus 10x is 11x. Then you're going to add 6. 11x equal 110. And so now when you divide by 11, you get x equal 10. And if you want to check it, this is 10. This would be 5 times 10, which is 50 minus 3, so you get 47. So then 47 would be there. 47 plus 47 plus 10 ends with a 4, and 4 and 4 is 8, and 2 more make 10. So 104, which is what you got here. So if you check your answer, it should all match up. Okay. The next one, this is 64, and you want to figure out these. So 180 minus 64 is 116, then divide by 2 gives you 58. Okay. Then this one, like this figure we've seen before, BA is congruent to FE, which is also to BD. So look for one of the BD choices, and this one says opposite, this one says connecting. So we need opposite because it's about legs. Legs, not the base. Any questions? Okay, this one's talking about an equilateral triangle, so you know over here these are 60s. And then the isosceles shares a side with it, which is the BD, and it's asking for the measure of angle ABD. So it's going to be 60 plus something. So here you've got 69 degrees. You got to multiply it by 2 because these sides are equal and these angles are equal. So you get 138, and then 180 minus 138 is 42. So then 42 goes here, and then you got to add those together, and you get 102. Okay, and then this one, the exterior of the bases is 160. So I'm going to put a 160 here. which makes this 20 because you're doing 180 minus 60. And then this one's also 20. So then for this you get 180 minus 40, which is 140. So for the base, it's 20, and for the vertex, it's 140. Now the next one is worded a lot alike. The only difference is this one says bases and this one says vertex. And so you draw it again, put this where this is 160, so you have 20. And then you do 180 minus 20 is 160, and then divide that by 2 to give you 80. So for the base angle it's 80, and for the vertex it's 20. Okay, we'll finish this up tomorrow. The review goes up to 31.